Well, now let's put it all together by finding all function values if we're given just a small amount of information. This first example we're going to look at asks us to just find the cosine of theta if I know that the sine of theta is equal to 3/5 and I know theta is in quadrant 2. Start by drawing a picture. I know theta is in quadrant 2, so we're over here. Okay, so theta is over here in quadrant 2. I also know that the sine of theta is equal to 3/5. We have to go back and we have to remember, how do I get the sine of a value? The sine of theta is equal to y over r. Y over r. So if the sine of theta is 3/5, then I know that y is 3 and r is 5. We can use Pythagorean's theorem, which says x squared plus y squared is equal to r squared, to find out what the missing value is for my functions. In other words, I can use Pythagorean's theorem to find out what x is. So we're going to say x squared plus y squared, which would be 3 squared, is equal to 5 squared, and solve from there. So I have x squared plus 9 is equal to 25. Subtract 9 to both sides. X squared would be equal to 16, and therefore x would be equal to both a positive and negative 4, right? Because if I take the square root of 16, I get positive and negative 4. This is where it's important that we drew a picture and we know what quadrant my value, my theta, is in. If theta is in quadrant 2, which is over here, then the x values for this quadrant 2 have to only be negative. So then I know that x is equal to negative. So from this I know that y is equal to 3, x is equal to negative 4, which we just solved, and r would be equal to 5. We're looking for the cosine of theta. I know that the cosine of theta would be x over r, and therefore it would be negative 4/5. Okay, let's look at that again. This next example is asking us to find the 5 remaining trig functions if I know that the tangent of theta is equal to the square root of 3, and I know that theta is in quadrant 3. So just to get my bearings here, I'm going to say theta is over here in quadrant 3. Okay, so tangent's going to be positive and cotangent will be positive, but the remaining 4 functions will be negative. So let's see how we can use Pythagorean's theorem to solve for that. Tangent is supposed to be y over x, and that's going to be the square root of 3, because I know the tangent of theta is the square root of 3, and I can write all numbers over 1. By doing that, it gives me both my y and my x value and allows me to solve for r. So if I know x squared plus y squared is equal to r squared, then I know 1 plus the square root of 3 squared is equal to r squared. So 1 plus the square root of 3 squared is 3, which is r squared. So 1 plus 3 is 4, and therefore r would be equal to 2. Remember that if I take the square root of 4, I get positive and negative 2, but r can only be positive. R is a distance or a measurement away from the origin, and distance is always positive. So now I have all the components I need to be able to find the 5 remaining trig functions, and I will do that for you. We've got sine of theta, which is supposed to be y over r. That's going to be the square root of 3 over 2. We have cosine of theta, which is x over r, and x is 1 over 2. And we have tangent of theta, which we were given, which is y over x, which is the square root of 3. From that, I can quickly find the remaining 3 functions. I have cosecant of theta, which is the reciprocal here. So it's the reciprocal, and it would be 2 over the square root of 3. We have to rationalize the denominator, which means this becomes 2 square roots of 3 over 3. Secant of theta is the reciprocal of 1/2, so that's 2. And cotangent of theta is the reciprocal of the square root of 3, or the square root of 3 over 1, and so we have 1 over the square root of 3, but you must rationalize the denominator, and therefore I end up with the square root of 3 over 3. And that's how we would find those 5 remaining functions.